Lee Clagett, by the way, is the guy who's going to be talking about this. He's one of the core devs, and his focus is on network decentralization, is what I would call it. Maybe you call it something else.
Yeah, that's pretty good.
Yeah.
This talk is specifically about encrypting the Monero P2P links, which has not been done yet. I guess I could just start without, so that
yeah, try to talk really close. I'm loud. Try to be as loud as me.
Yeah, wait, okay. Yeah, so I'm going to try to just talk through the first couple slides because there's really not much to see. So there we go. So the title is just hiding the ring. So this is about the importance of P2P encryption. There's certain cases where the real member of the ring can be revealed still currently today, and it's a result of this unencrypted traffic. So this is what this talk is about primarily. So there's a blank slide, skip ahead at least 2. Right, so for those that don't know, I've been around since 2016 when Fluffy Pony encouraged me to come to Monero, and I've been sort of crowdfunded since 2020 to do various, mostly it's been Monero core related stuff, a lot of P2P stuff, and so there's been optimization work, there's been kind of just all over the place, really. A lot of wallet work, too. So go ahead on to the next slide. So the primary, at a high level, most of Monero is focused on blockchain privacy. That's a big difference between Bitcoin. But there hasn't been a lot of talk about TCP privacy. Now, this is important for the highlighted in red is for coin tracking. There's also issues with, obviously, as you add encryption, there's a higher probability of errors like remote code execution and data dumps like log4j. But for Monero's purposes, this added security risk is probably worth it because you can actually track coins still today at the ISP level. So if you skip to the next slide, I don't know if you can see I had a cool diagram. So when you go online later, you'll see this. But basically, if an ISP can determine that 2 transactions came from the same IP, the change address appears in the ring signature. So if they know that both transactions came from the same IP, they effectively know the real, I'm sorry, can you skip to the next slide? So I'm not sure if you guys can see this in the back there, but basically the change output appears immediately in the next ring signature at times. So if the ISP is monitoring all traffic and you're not using I2P or Tor, they're still going to know the real ring member effectively. So this is the primary focus of the P2P encryption, is to close this loop, to make sure that even if you're not using I2P or Tor, that the real ring member is still hidden from outside passive observers. So if you skip, let me see the next slide here. Yeah, skip to the next slide. So at a high level, what's happening is I2P and Tor protects against both ISP spies and P2P spies. So the difference is the ISP would be, well, we won't mention any names, but your cable company, they could monitor your traffic. I2P and Tor protects against that because it's encrypted. They also protect against P2P spies. So this Bitcoin has this big issue where some of the blockchain analysis companies connect to tons of nodes in the network, and their goal is to identify where the transaction started from. They can do this without being an ISP because it's all statistics on the way the transaction gets propagated. So Dandelion++, which I implemented, that was part of the CCS I did probably 2 years ago. This was actually funded and researched for Bitcoin. They still haven't implemented it. So Monero has been using it for at least 18 months now. This protects against those P2P spies. This protects against those blockchain analysis companies that were connecting to tons of nodes. It makes them harder to track internally that way. However, if they coordinate with an ISP, they can still do some tracking because the traffic is unencrypted. If you're concerned about that right now, what you do is you use I2P or Tor. But that's not always available to some people aren't using it. And so we'd like to improve this because anybody that's not using I2P or Tor is effectively leaking their real ring member, which hurts everybody's privacy. So we pretty much have to implement some encryption. It was just a matter of, do we use TLS/SSL, or do we use the new fancy noise protocol, which Lightning Network is using, WireGuard is using, Bitcoin is doing something similar but slightly different. I2P is also, as I'll discuss, using something similar. So, oh, you've already skipped to the, well, yeah, we can go back to, yeah, so the only thing I was going to point out is Monero's design is going to be more similar to what I2P is doing. So I2P was based on the noise protocol, and they made some adaptations. And Monero is going to be doing, it's not going to be competing with I2P. It's going to have a similar design in the way the channels are encrypted. And so I2P was designed to be more stealth-like than TLS. It's harder to identify with DPI engines. So this is where the ISP may try to run a pattern matching search to determine what the traffic is. I2P has made this a little bit more difficult. It's not impossible, but you have to monitor, you actually have to join the P2P network to know that someone's using Monero is the ultimate goal. We can't really defend against that because if they're part of the network and they're collecting IP addresses, they're going to know that you're using Monero. But we prevent a lot of this passive spying, and we prevent sort of this ring member issue that I just discussed a second ago. So go ahead into the next slide. This is pretty technical. Someone like the Nothers will love this. I was already showing them actually this because they had not actually seen this technique that I2P uses. But basically, from byte 0 on, it should all be effectively random bytes, or it should look pseudo-random, I think would be the phrase. So this will make it harder for ISPs to actually detect that it's Monero traffic without doing additional work. Meaning, if you use TLS, they can pretty much tell it immediately that it's TLS. This technique, they won't be able to tell whether it's Lightning Network, whether it's I2P, whether it's Monero or any of these other new projects that are using noise protocol. They actually have to do a little bit more analysis to determine what is inside the payload. Now, typically they can determine based on just packet sizes and everything, but it's not dead simple. They actually have to do a little bit more work, I suppose. The primary benefit to Monero is preventing like the ISPs from just blocking Monero traffic. That's one of the reasons why I2P does it this way. And that's a secondary use case. The primary use case is just making sure that it's encrypted. So go ahead and finally jump to this. So the one problem with this approach is we still have default port numbers. And so I'm going to be talking to people a lot about that today. There's probably going to be a mode for super paranoid people where if it's using the default Monero port number, it won't even use that. That'll make it really hard for ISPs to determine they're using Monero. They'll actually have to join the P2P network to actually monitor the traffic. As I said, the entire stream is pretty much, I should have said pseudo-random. It says random. It's actually pseudo-random because it's not, if you know what's being sent, you can actually decrypt it. Otherwise, because if it was truly random, the receiver would, couldn't do anything with it. The only downside of this is if we make this mandatory, nodes that have not been online since a couple hard forks will have to rebootstrap from the very beginning. Basically, the way it's going to work is that every IP port pair will have a public key, which is used as part of the encryption technique. But if they've been offline for a couple hard forks, they won't have any public keys. So you pretty much have to start from the beginning. They have to reconnect to what's called the bootstrap nodes. For those that don't know, there's hard-coded IP addresses and DNS addresses. So even though it's decentralized, it has to start with a fixed, centralized starting point to learn other IP addresses of the network. Once it's been bootstrapped, it's usually pretty secure as far as decentralization goes. So I don't really have a good technique for that other than we slowly roll out this encryption, and I have plans for that, but it'll have to be, if you haven't run your Monero node in over a year, you basically have to rebootstrap from the beginning. So I don't really have any, it's going to have to be that way, I think. So go ahead into I think there's just more, right. So to be clear, this is not going to be competing with I2P and Tor. The goal is primarily making the link encrypted so ISPs cannot easily determine your ring members and basically do blockchain analysis that way. I kind of mentioned already, it's not going to be authentication based. It's going to be very similar to what Bitcoin is doing. The term they use is opportunistic encryption. Basically, authentication is really difficult because you have to associate a public key to an IP address. And the best way to do that is with a blockchain. And so I realized when I was going down this route, I was basically redoing Namecoin in Monero. So I stopped and said, we're going to do version 0. We're not going to do authentication. It's going to be sort of what Bitcoin is doing. It's opportunistic. Opportunistic means someone could say, hey, this guy in the front row, I know his IP address, I know his public key, but they could be lying, and it could be a man-in-the-middle technique. We can't really prevent that unless you do use a blockchain to store all this information. So I talked to Sarang, and he sort of gave me this look like, I'm solving like 4 problems at once if I go down that route. So version 0 is going to be similar to Bitcoin and what Lightning Network is doing. It's called opportunistic encryption. It attempts, based on what the peers are telling you, to connect and decrypt the packets. In most cases, this will be no issue, but there will be rare edge cases where there'll be man-in-the-middle techniques if someone was really aggressive. However, to pull this off, they will have to connect to the Monero P2P network and give false information to people. So this won't be passive. It'll be an active attack which can be spotted by other people in the Monero network. This is in contrast to a technique of decryption where they can man the middle without ever having to, they can do a man in the middle without ever connecting to the Monero network. So it will be designed so that they have to connect to the Monero network to pull off the man in the middle. And so in theory, we can spot this. That's the difference between, I know it's pretty high level, but there's actually 3 levels. There's no authentication. There's sort of this middle layer where you actually have to connect to the network and fool people. And the third one is you use a blockchain for it, which is really hard to spoof. But we're effectively redoing Namecoin at that point. And so this is what the last bullet point about. I'd say no authentication. That's probably technically incorrect. There's some, but it's not what people expect. Because when I propose this, everyone goes, well, why isn't there like SSH authentication? And it's like, well, decentralized authentication is a big problem. It's literally its own blockchain. That's why Namecoin exists. So go ahead on to the next slide. So the next slide, I'm talking about how are we going to upgrade potentially to new things. As part of the handshake, there's going to be a version number. And at each hard fork, I think my plan is there's going to be 2 allowable versions of the encryption. So the recipient will try the newest version number, and if it fails, we'll then fall back to the old version number handshake. And so that will how we'll handle upgrades. We'll have at least 2 active at all times. After thinking about it some, we're probably going to have to make encryption mandatory on the network because of this privacy leak. So at some point, there'll be a release where encryption is optional and the fallback is the current unencrypted mode. And then the next release after that will be mandatory encryption, and then future upgrades will have 2 encryption versions going. I think that's how we're going to have to handle it because, again, because of this privacy issue, I was thinking about making it permanently optional for security reasons, but the problem is privacy. We're probably going to have to make it mandatory and roll it out that way. So I think I've got most of it covered, and I'm sure if Moo's here, he'll give me, he or she will. If you know Moo, he or she, I've often wondered whether Moo is always quietly sitting in these talks. But I think Moo just sits at home and just shakes his head at me. So again, I talked about some of these concerns. One of the concerns is that this custom P2P traffic doesn't actually hide the Monero traffic completely. That's a really difficult problem to do because if someone really wants to know that you're using Monero, it's pretty hard to, if there's a 10-person team and they're like, we're going to find out if this person's using Monero, it's pretty difficult to defend against that. So at first I didn't know whether we should use a noise protocol because it's a lot of custom encryption. But then Sarang reminded me that Monero is nothing but custom encryption, so why not just, this is actually pretty simple, but compared to Bulletproof, this is this is pretty basic. I can see. So the other problem I'm a little worried about is that this will induce some overhead latency, so block propagation will slow down, and this is probably the reason why Bitcoin has never actually implemented this mode. They've talked about this. You can see me at least at least 6 years, maybe 8 years ago, talking on Bitcoin Dev and giving them suggestions about their encryption mode. They've never actually rolled it out, and I think one of the issues they have is it slows down block propagation because the decryption takes CPU time, and this slows the latency down. So before you can even validate the block header, you have to decrypt it. So with Bitcoin, they're all about decentralized mining and and actually so is Monero. So, but unfortunately, because of this privacy issue, I don't really see. I'm going to talk to you're Seth, right? Okay, I've never met him before, so this is always great. But I'm going to talk to some people. I don't see how a way around. I think we're going to have to make it mandatory, despite the latency issues. There can always be techniques where on the back end, core mining groups send messages back and forth without encryption, possibly. I mean, we can't really prevent that entirely anyway, so we might as well just let it happen. And then the other concern, what was the other? Oh, right. So the other concern is that this will potentially cause some more denial of service issues. So when you're running your home node, a lot of people don't think about this, but you're running your server at your house, and there's potentially that someone could just overload your home server. So, well, I have some mitigation techniques already discussed in the slide. No one seemed to have any issues with those, but there'll be additional modifications to the way Monero rejects incoming traffic so that it doesn't get overloaded doing new decryption. And so I think, yep, we'll go ahead and I think I've pretty much covered all the bases. So that this is for any questions. Also, I did mention in Doug's talk that I had some wallet ideas. So I have other project ideas, but if you want to talk about those, we'll talk about that after the talk. But if there's any questions about. So the question was about additional latency on the verification time, correct? When you receive a transaction? Increased latency. Oh, all right, so you're talking about relative time. So relative time, there's so much time spent. The bulk of the time is actually spent verifying transactions if you look at the timing analysis. So what typically happens is when you get a block, ideally you know all the transactions up front, because the heaviest lifting is actually doing all the bulletproof stuff and doing the pretty much all that, like all the confidential transaction stuff. The block header is fairly quick because it's hashes in. I don't know. My guess is that it's probably going to be slightly more, or no, because I'm always saying. So to initiate the connection is going to be fairly expensive. That's why I'm worried about denial of service. But the decryption is probably going to use Cha-Cha, so it's going to be fairly quick. As far as I've never measured, I'm going to take a guess and say the block verification could be quicker, simply because it should be quicker, but in the code it's not. So it has to pack everything into a specific big pattern, make sure that it's valid, and then do a bunch of hashes. I take that back. The decryption is going to be faster, actually, because we can optimize that code. That'd be my guess. But this is just, I haven't run the numbers, but we may have to run those numbers if you're curious. But it won't be, we're talking probably like 100 milliseconds to decrypt at most or something like that. I don't know. Right, it's got to be less than that. I think it's probably in the microseconds, actually. I don't know. Do you know what Cha-Cha decryption? Aaron would know, but well, we can run those numbers. The basic problem is that in my opinion, there could be some optimizations done in the block header verification also. So there's that. I couldn't hear what you just said. Oh, right, I forgot about RandomX entirely. Right, so yeah, the decryption time is going to be way faster. Sorry, I forgot about the craziness, not craziness, but it's interesting. Yes, the decryption is going to be much, much faster. You're right, I'm sorry. So that, and so actually compared to Bitcoin, that's probably why Bitcoin cares, because Bitcoin has a much faster proof of work algorithm. And a lot of it can go to hardware. We can't go to hardware the way Bitcoin, they can literally send, most CPUs have a SHA-2 instruction. They can just fire their block headers at, and we don't. That's the whole point. We have to do a bunch of random instructions to verify it. So yeah, I forgot about that entirely. Yeah, the decryption is gonna be much faster. It's gonna be, I don't know, like probably like 1,000 times faster or something like that. Was the question, what is the risk of running a node? So the biggest risk that I've been concerned with is adding some remote code execution vulnerability or adding some log4j stuff where because you're adding encryption, decryption, you have to copy the packets more. There's a lot more just overall code to handle it. The most complicated code is in the initial setup. Once the handshake has been done, the decryption is pretty straightforward, but there's always a risk of doing a heartbleed kind of situation where, oops, we're leaking a bunch of secret material, or oops, like log4j, we're just dumping out logs unintentionally. So there's always a risk, but I think in the end, because these ISPs can effectively break your ring members, we're probably gonna have to just accept that risk, like we've accepted confidential transactions. It's gonna have to be just unacceptable. Now, thankfully, there's tons of, I'm not basing this, so the actual handshake is based on the noise protocol, which has been verified, been formally verified by researchers. It's not entirely new. It's just that some of the obfuscation techniques are new to, are unique to I2P that I'm using. But otherwise, it's pretty much a protocol that someone else has designed, that's been formally audited. So there's little risk of it bombing that way. It's just implementation risk is the main issue. Does that answer your question? I got the, so you're running a node and there's something else on your computer? Can you hear what it can, maybe one, yes, it's going to add some risk. It's just hard to define a risk because you're effectively running your own server. It would be like it's like asking, does running a HTTP server at house increase your risk of being hacked? And the answer is yes, because you weren't running a node before, so by definition, it's increasing your risk. It's impossible. I'd be lying to you if I said otherwise, because there's got to be like a math theorem for this. If you're running a server at your house, it's increasing the risk. I know, I get it. But here you
go. Real quick question, or a note too on what you're mentioning about the decryption. I definitely don't view that overhead as being too problematic in Monero, since we don't have these highly optimized Monero pools, and P2 pool as well will, I think, lessen the impact since you'll have individual miners. Although I guess
yes,
that's a whole other thing of worms.
I've got an incredible amount of patches that no one's ever seen where I'm attempting to optimize P2P stuff, and it usually stops dead because I'm like 98% of the way there, and I realize, oh, this isn't gonna work at the last second. But there's lots of optimization work to be done at the P2P layer. So like you said, it's not really that much. And then I forgot about RandomX. RandomX, for better or worse, dominates so much of the CPU time that the decryption is gonna be, the Cha-Cha decryption is gonna be so. For those who don't know, Cha-Cha, as far as I know, there's no hardware implementation that accelerates it, but it's been designed to work with all hardware efficiently. So even if you're running an ARM processor, it's going to decrypt pretty quickly. Where AES, that's not the case. It's sort of heavily dependent on hardware, whereas Cha-Cha has been used for SSH and a lot of the real-time protocols because it's very quick to decrypt, even with ARM processors or even with some of these other weird MIPS processors that like Ubiquiti uses, no one else does.
A quick question about what you mentioned earlier as well. You mentioned not allowing fallback to plain text or
eventually,
clear
right?
Encryption or clear communication. That seems a little bit dangerous to not allow. I understand not having it as the default, but not allowing it sounds pretty risky. Just if something's broken, you could essentially bring down the entire P2P network. Or if there was a specific DOS vector that required.
Yeah, it was a proposal I've done, and I'm not sure whether I'm actually going to implement. Because I think what I'm going to do initially is that it's going to be optional, and it's going to be proposal like the first go around. There's going to be it really doesn't even have to roll out with a hard fork, but there's going to be a release where encryption comes on by default, but it's optional, and then we'll delay that what you're proposing to, because like it needs to get up and running first, and then we can have that discussion second. But I agree, that's one of the issues. Like if I botch if there's broken code in that complex header thing, effectively the whole P2P network gets locked out, and miners might be mining with each other, but no one really knows about it. Like there's, for those who don't know what Seth is referring to here is, there's lots of weird edge cases where you can effectively create a network fork, like as if the Great Wall of China had just sanctioned off a whole bunch of machines. You can do that yourself by writing buggy code. And so this has happened. This definitely happened in the great world of cryptocurrencies, and we hope to not bring this anti-feature to Monero.
Yeah, I think definitely a fallback as just a last case, but keeping the default as encrypted is a key thing long term.
Yeah, I'm not sure. It'll have to be. What we don't want is. I think I think in the end it'll be okay, because what we don't want is people aggressively choosing it. But if they are. No, I think you're right. I'm going to talk to you about this later, but I think you're 100%. We're always going to have that fallback, because if the person wants to reveal their ring member, they're going to do it anyway. So we might as well just aggressively make it the default, but never enforce it, right? I think you're right on that.
Yeah,
okay.
It's opt-out privacy, just like the Monero protocol. You default get it,
Yeah,
but you choose to opt out if you want.
I keep forgetting that in my head. I'm like, but people are going to choose to opt out, but you can't. Yeah. So anyway, so all those slides are wrong. Seth just pointed out we're gonna push the encryption mode, but we're not gonna make it mandatory. And then I think between hard forks, we'll definitely have a mode where there's only 2 in cycle at a time, because that's the only way to really handle the version upgrades. If that's the handle, if someone wanted to do a blockchain thing where we started associating public keys to an IP address on the blockchain, that would really make it hard to do man in the middle, and that would really make Eclipse attacks difficult. But then would have to have basically Namecoin embedded within Monero, and I don't know that we want to do that. Well, he's gonna have to yell. He's gonna have to get a mic.
Hold on, let me get your mic.
If only he commented on the PR, not. There's like 1 million PRs though.
You mentioned that nodes that are a couple hard forks behind are going to have to resync from the Bootstrap nodes.
So in the end, as he was just commenting, probably not now. Okay. Because if we don't make it mandatory, we might be able to say. So ask your question first, because it may still come up, but go ahead and finish your question. I apologize, I cut you off.
Are there any efforts currently out there to decentralize the process of bootstrapping?
Right. Everyone asks about this. You really can't do better than. So everyone comes up with this idea, and the problem you have to remember is you need a starting point. So everyone comes up, well, why can't we decentralize it? Well, you can. Like, one of the ways you can decentralize it is you can share a bunch of IP addresses and share your own custom version with each other in this room, and then bootstrap off other people in the room. You just have to make sure that collectively you all get back to the same net. There's lots of confusing scenarios where you end up on an entirely separate network because you communicated with these 3 people and they just, they worked with some government somewhere, and then you're off on your private Monero and don't even know. And then there's the other possibility that most of the techniques actually devolve to the same centralization technique. So this is a fight that we had. I hope he's in it, but Covery, the guy who was paid to develop Covery. We would argue with him constantly that he had all these ideas, but the problem was he just made it really complicated, and it just devolved to the same. The best you can really do is maybe have multiple projects with different IP addresses with different owners that all bootstrap to the same network. Beyond that, I don't see how you can really do it. You basically have to have multiple Monero repos where the only difference is the hard-coded IP addresses that all point. But otherwise, because you have to at least know one member that's of the legitimate network to get into the network. If you don't have one of those, you can be. That's one way you can get an Eclipse attack. If you never get a legitimate IP to the real network, it's like a chicken and egg problem. It seems really simple until you realize, well, how do you even know what the real network is?
Yeah, I remember back in the day, the only solution was custom DNS servers that would return what you're looking for. So
yep, we have DNS servers. We don't really use them. I think the only other option is we just have multiple repos. I don't know if anyone's done that. The way, and Seth can tell you, the way we handle it is it's some big time contributors are allowed to give their own IP address of a node they're running. So there's several people that are completely anonymous, I think, to pretty much everyone in the community that have submitted a patch, submitted their IP address, and it's hard-coded in there. and who exactly is running and managing that, other than there have been a long-time contributor on GitHub. That's probably the best way I've seen us to anonymize it. And that one's actually pretty effective because there's at least 2 IP addresses on there. I'm not sure if anyone fully knows their full identity.
Thank you.
All right, any other questions, guys?
Good thing there's a break after this, right? Everyone can just...
Can you hear me?
Yep.
Okay, so this may be off topic, but I was wondering, like, have you talked about, is there going to be like a layer 2 for the Monero blockchain? And if so, what's going to differentiate from layer 1?
That is, someone else is discussing that here today, I think. I saw that in the...
Yeah, no, we don't have anybody that's going to talk about a layer 2 specifically on Monero, not like a Lightning-esque thing. We have people that are going to be talking about basically interoperating with Monero. So Thorchain and Haven, well, it's really Thorchain. And then we have somebody that's going to be talking about Bitcoin to, Monero to Ethereum atomic swaps. So nobody talking directly about a second layer, but effectively Monero being able to interoperate with other cryptos. But there are talks that I've done on Monero Talk.
Fine. One person to find is Justin Berman because I talked to him yesterday. I'm convinced that you can't have privacy on Lightning Network, so it may reduce privacy via layer 2. So that's something else to think about.
But yeah, bottom line, there's absolutely no reason why you can't have something like a Lightning Network on top of Monero. And there are people that are already writing papers about it and talking about it. We were supposed to have one of those guys here today, but he's not here. But you can go to Monero Talk and you can see some of my older talks and we have discussion there.
The reason why I asked is because, like, a speaker earlier was speaking about how, like, certain protocols can get kind of stale. So I was wondering if there's going to be any upgrades to XMR, because what we don't want is it to get stale. And
Monero, so a good one to listen to is Justin just did an interview outside a couple talks ago. And if you can find that online, it's great because Justin sort of actually talked about this with Raphael. Monero does upgrades because we're focused around privacy. So it's pretty easy for us to upgrade. We say this feature helps with privacy. And everyone reviews it and agrees, and we do a protocol upgrade. So there's less contention than Bitcoin because Monero has a specific focus where Bitcoin almost is like, Bitcoin at this point is almost claiming to do everything. Whereas Monero is much more narrowly focused on fungibility, digital cash, and privacy. So protocol upgrades are, as long as they're within that realm, they're easier. If they're, let's add a Bitcoin scripting language to it, then that's probably not gonna go over too well unless there's a lot of work done. But typically protocol upgrades are much easier than Bitcoin because there's a more core group of people focused on a specific goal as opposed to whatever Bitcoin is trying to do at this point.
Yeah, I think the point that the speaker was trying to make earlier is that you need to evolve, especially if you're trying to be a privacy coin, because it's a constant battle, and that is definitely part of the Monero culture. Monero used to, up until recently, was upgrading essentially every 6 months. The goal is to push, extend that amount of time as time goes on, because ideally you won't need to upgrade as much. But even now, today, Monero is still upgrading every so often, upgrading the protocol.
just one more question. So this is kind of maybe off topic, but Web3, like there's so many discussions about Web3. So how is Monero going to play into Web3?
So I don't know much about Web3 other than I do have some other wallet ideas. Multi-currency wallet, and I was talking to Doug earlier, I really want to do a communication wallet surrounded around Monero. So it's not really Web3 other than group chat communication and I have some other ideas about this. Oh no, actually, then I also, we'll talk about this later. This isn't, I have some ideas for it, but I don't know that anyone's really, that there's any core group of people focusing on it, but I do have a couple of project ideas about that, but whether they come to fruition, I can't say because I've got a lot to do.
Yeah, my response to that, Monero digital cash first and is trying to get That's its primary focus. But like I was saying earlier, Monero is interoperating with other protocols. Secret Network is one of them. You can do DeFi essentially with Monero, with wrapped Monero. Fluffy Pony just announced recently, without giving too much details, on how he's working on some kind of wrapped Monero concept. So you'd be able to do DeFi with that. Like I said earlier, we're going to have Thorchain here. Thorchain is currently figuring out how to add Monero, so you'd be able to seamlessly swap between Monero and other cryptos that are already connected to Thorchain. Haven is one of them that people are interested in, and Haven is built on actually the Monero protocol. So the Haven team is the team that's helping to do that work to now add Monero to Thorchain. But to answer your question, that's going to then lead to other things, right? So like DeFi on Monero through these other protocols. I'm gonna wrap it up here just so we can stay on schedule. Thank you so much, man.
Yep.
Greatly appreciate it.